Doodle tutorial, Working with Masks. In this short tutorial, you'll learn how to create, organize and use masks in Doodle, so your process flow stays clean, consistent and fully documented. Let's start by opening Doodle and arranging the layout to focus on the mask cross-section and GDS panels. What is a mask? A mask in Doodle represents the 1D pattern applied during lithography or any pattern-driven steps. You will attach masks to steps like expose and develop, dice, or wire bond. Masks are stored in your project and can be reused across multiple steps. In Doodle, each mask is comprised of 1000 pixels that can be turned clear, 0, or dark, 1. Creating a mask from scratch. Click Add Mask. Give your mask a clear short name like Pad Clean or Metal. You can keep the default color or pick a color for quick visual recognition. Select the Coarse, Medium or Fine Edit tool to control larger or smaller groups of pixels. You can also choose between Set Mask Pixels Dark, Set Mask Pixels Clear or Toggle Mask Pixel Polarity to control how mouse clicks affect the mask. Click the mask area to turn pixels dark or clear and create your structure. Creating masks from GDS files. If you already have masks in the form of GDSII files, choose Open GDS Mask, select your GDS file and click Open. You can now see a top view of the top cell of the GDS file. If you are not interested in the top cell, you can select a different cell by clicking the GDS tree button. This will open a hierarchical view of the GDS file. Here you can choose the cell you wish to see. Next, use the Cross-Section Line Draw tool to draw lines on your GDS view. These lines will later turn into 1D masks Doodle can use. You can draw a line by clicking the starting point, dragging and releasing it at the end point. If you hold the Shift key while drawing, the line will snap to horizontal, vertical or 45 degrees diagonal angle. You can draw more than one line to highlight different regions of interest. Here we will run a line through the comb drive and a second line through the pad area. If you are not happy with the line position, you can drag either endpoint or delete the line using the Cross-Section Delete tool. Once you are satisfied with the line locations, click the Cross-Section button and Doodle will create 1D masks that shows the specific cross-sections of your GDS view. Note that the left side of the mask illustrates line 1, the comb drive, and the right side of the mask illustrates line 2, the pad. You can rename each mask, change the color, visibility and transparency of each layer using the control icons of each mask. Rename Mask 1 to Cavity, Mask 2 to Comb, and Mask 3 to Pads. Using the masks to pattern the structure. Let's use these masks to build a structure. Spin a photoresist layer on the structure. Use the cavity mask to pattern the photoresist before etching. Etch through the photoresist and the silicone. Continue building the structure step by step. The structure is now finished. Let's illustrate stealth dicing of the wafer. Add a dice step from the wafer menu. Notice that this process requires a mask. Let's add a dicing mask manually. Click the Add Mask button. Rename the mask Dicing. Select the dicing mask from the drop-down menu. Nothing happened because the mask is all clear. Make some pixels dark, as explained before. The structure updates in real time and shows the dicing lines. You can move the dicing location and width by repainting mask pixels or by using the push and pull buttons. Notice that when changing any of the GDS-generated masks, the GDS view is surrounded by a red frame. This indicates that the GDS and 1D masks are no longer synchronized. You can always press the cross-section button again to regenerate the GDS masks. Now the red frame disappears. Conclusion. Masks and photolithography are inherent parts of any semiconductor process flows. They are used to define features on silicon. Thank you for using Doodle. We hope this tutorial helped you understand masks and how they are used in designing your very own MEMS or semiconductor products.